would lead to the conservation of energy and momentum. Invariance under this would lead to the conservation of angular momentum. And this implies both of them. Okay. So now here, but under these, under the, so these are Poincare transformations, and under the Poincare transformations, H alpha beta or alpha beta equal to alpha beta with under Poincare transformations. So H alpha beta, the two-dimensional auxiliary field, which is the worldsheet metric, so this remains invariant under the Poincare transformations. It does not change, and it does not lead to also any new conservation laws. Okay. Now here we have to remember that these transformations, you see, some of these two or individually, they do not depend on the index alpha, which means they do not depend on sigma alpha, or they are independent of tau and sigma, and therefore they represent global symmetries. Okay. So local symmetries, local transformations, they are always required to be functions of tau and sigma. Then you talk about the local symmetries, otherwise they are global symmetries. So they are the space-time symmetries or the global symmetries. Okay. This is one important point. And then we can now, so the worldsheet symmetries would be quite distinct from these symmetries or from the space-time symmetries. So what are the worldsheet symmetries? How do we study them? What happens to the could I remove all this? Yes. Okay, so we next talk about the worldsheet symmetries. Now, worldsheet symmetries are again can be divided into two different parts. One are the symmetries resulting from the reparameterization symmetry or the reparameterization invariance, also called as the diffeomorphism invariance, which are the transformations resulting due to a change in sigma alpha. Okay, tau and sigma, if they change to tau prime, sigma prime, and if the theory is invariant under them, we say that this is the reparameterization invariance. Okay, and additionally, and we will see that this would lead us to two gauge parameters in the theory. Okay, so because they depend on sigma and alpha, they are local symmetries. Local symmetries are the proper gauge symmetries. Okay, so this is one reparameterization invariance or diffeomorphism invariance, and the other one is Bayer invariance, which changes the scale of the metric. And this also results in one new or different gauge parameter. So two resulting from reparameterization invariance and one resulting from the Bayer invariance. So we have three gauge parameters in our string theory. Okay, so polyakov action would have three string gauge symmetries, which are given by three gauge parameters. I denote one of them by omega and two of them by zeta alpha, where zeta alpha can be zeta 0 and zeta 1, and we will see how they arise. So I would denote them by, let us take one by one. So now these are the local symmetries. These are the local symmetries, and they depend on sigma alpha or tau and sigma, and they, zeta alpha is one parameter, zeta alpha tau sigma, zeta 0, zeta 1, each one is a function of tau and sigma, and I would have another parameter omega, which is also a function of sigma alpha, and I would in turn write it as 2 omega, where little omega is also a function of sigma alpha, or is a function of sigma and tau. So these three gauge parameters would appear in the picture. Now let us have a look. So sigma alpha goes to sigma delta, sigma delta, then I don't need to put the arguments, but okay, this, and this goes to sigma alpha minus delta alpha, sigma alpha. So we consider a transformation in the worldsheet coordinates. Okay, we consider a transformation in the worldsheet coordinates, sigma alpha going to sigma delta alpha, which is sigma minus zeta. Okay, and we try to see what happens to in this case. So x mu of sigma, this goes to x mu delta of sigma delta, or this goes to x mu of sigma delta. This goes to x mu sigma plus zeta gamma del gamma x mu sigma, and if I identify it with x mu plus delta x mu plus order zeta square, higher order terms in zeta, we need to remember that all these parameters, zeta as well as omega, they are infinitesimal quantities, infinitesimal parameters. Okay, so when we take higher order terms, they ought to vanish. Okay, we could neglect them. That's the point. So with this identification, I would have delta x mu would be zeta of gamma del gamma x mu of sigma. This is a result of the change in x mu because of this reparameterization, sigma going to sigma, sigma going to sigma tilde. Okay, so if sigma goes to sigma tilde, x mu goes to x mu plus delta x mu, where delta x mu is given by this. Okay. Now, what happens to h alpha beta? Maybe we could retain the result here and delta x mu is zeta gamma del gamma x mu. And we might erase this, and we want to consider under the same transformation sigma going to sigma tilde what happens to the metric world sheet metric h alpha beta, okay, which is also dynamical. Okay, so it's a dynamical field essentially. So now h alpha beta sigma, it goes to h tilde alpha beta sigma tilde, where sigma tilde goes like this. Now this has to transform like second rank tensor. So this is or maybe I could write here. This goes as del sigma gamma del sigma tilde alpha del sigma delta del